Greetings, everyone. My name is Stephen Boggs, and I'm the Dean of the Division of Physical Sciences. Joining me is Dean Al Pisano from the Jacobs School of Engineering. We are thrilled to have this opportunity to introduce UC San Diego's new Institute for Materials Discovery and Design to the Foundation Board. Materials science is an incredibly broad field covering everything that makes up the world around us. And materials drive technology in ways that we don't always appreciate. Innovations in materials enable us to create smaller and more powerful computers, make batteries more efficient, solar cells more prolific, create synthetic tissues for medical applications, and much more. Modern technology is largely a reflection of modern materials. UC San Diego has, from its founding, been a leader in the study of materials. Several of our departments are largely focused on materials research, including physics, chemistry and biochemistry, nanoengineering, bioengineering, and mechanical and aerospace engineering. Our research efforts have been interdisciplinary from the start, but as the university continues to grow, we want to keep this work collaborative. On September 29th of this year, Dean Pisano and I were thrilled to officially kick off the new UC San Diego Institute for Materials Discovery and Design, a joint initiative of the Jacobs School of Engineering and Division of Physical Sciences. We are grateful to Chancellor Khosla and Executive Vice Chancellor Simmons for their strong support of this initiative. The Institute endeavors to create a unique, world-class facility that will enable and attract unprecedented levels of support for innovative, interdisciplinary, inclusive research and training in the science and engineering of materials. The purpose of the IMDD is to enable accelerated discovery and design of materials with improved properties for application in energy systems, electronics, information technology, telecommunications, space systems, and medicine. The mission of the IMDD is to transform research, education, and training in materials science and engineering across the campus. We are thrilled to have with us today Dr. Shirley Mang, Zable Professor of Nanoengineering, who serves as founding director of the Institute, and Dr. Michael Saylor, Distinguished Professor of Chemistry and Biochemistry, who serves as founding co-director. They will give you much more insight into the Institute in a few moments. The IMDD includes several important initiatives. First, the Institute will build on UC San Diego's resources, such as the Nano 3 facility and the San Diego Supercomputer Center. IMDD is establishing a world-class nanoanalytical instrumentation facility within the Nano 3 facilities in Atkinson Hall. The state-of-the-art Thermo Fisher Scientific Transmission Electron Microscope, or TEM, is dedicated to materials characterization. Second, the campus-wide Materials Science and Engineering graduate program is a critical component of the Institute. IMDD develops new training and curricula in data analytics and machine learning for application to materials science and engineering, as well as nanoanalytical nanofabrication training associated with the Nano 3 facility. The Institute is working towards establishing new graduate fellowships in materials science through collaboration with industry, foundation, and community partners. Next, as the Institute builds up the campus research instrumentation capability, UC San Diego will be better positioned to compete for large, multi-investigator materials research center awards. We've already seen our first success with the award this past summer of a highly coveted National Science Foundation Materials Research Science and Engineering Center Award, led by Professor Saylor. And finally, the Institute hosts a distinguished seminar series intended to catalyze new collaborations while raising UC San Diego's national profile and international stature. Physical sciences plays a unique role in materials research and one that strongly complements the role of engineering. Materials research in physics and chemistry and biochemistry is largely focused on understanding the basic properties of matter by detailed understanding of the underlying physics that governs how atoms and molecules come together and interact to create completely new systems. Our scientists are less focused on the application of the materials and more focused on understanding and creating whole new classes of material. Two areas of modern research are particularly ripe for transformative materials discoveries. First, detailed understanding of quantum physics coupled with the unprecedented power of supercomputers is enabling us to design materials with novel properties from the atomic and molecular scales upwards. Key to understanding this is emergent phenomena, how quantum interactions between atoms and molecules can produce completely new properties like superconductivity that the individual atoms and molecules do not exhibit. Breakthroughs in this area allow materials researchers to create whole new classes of materials from the atomic level upwards. In the process, these new quantum materials allow us to refine and improve our understanding of quantum physics. And second, modern biophysics and biochemistry have revolutionized our view of living systems, enabling us to understand how living cells function from the molecular level upwards. This molecular understanding of the processes of life enable whole new fields of research, incorporating these molecular tools into synthetic matter. Synthetic biology creates materials with properties only seen in living organisms. By studying these synthetic materials, researchers are getting a better understanding of the processes of life itself. Let me hand this over to my partner in this endeavor, Dean Al Pisano, who can better elaborate on the role of engineering in this effort.
Good morning, everybody. My name is Al Pisano. I'm the Dean of the Jacobs School of Engineering, and I'm here to help celebrate the launch of the IMDD. I want to thank Steve Boggs for that wonderful introduction, and I want to point out my hopes, not only for the great success of the IMDD, but for its role in creating a new kind of student, a student that I like to call someone of the innovation workforce. Now, I appreciate Steve's sentiments, and indeed, Steve Boggs and I are very strong partners in reconnecting engineering and the basic sciences. And we're doing this because this is core to who we are as a university. My hope is that the IMDD becomes the first of many things that we build together that can capture more of the wonderful research value that we are actually creating. I have a concrete proposal for how we might do this, and I call this the Innovation Centers for Platform Technologies. And indeed, I see the IMDD as the first of these. What is a potential future of the IMDD? We'll hear from the faculty how it got started, where they are now, and where they're going. Let me paint a picture of where they might arrive. So I believe the IMDD can evolve into a wonderful innovation center for platform technologies. These are public-private partnerships that tie together engineering and basic science in pre-collaborative collaboration. They attract federal funding to protect the U.S. research enterprise. They accelerate the creation of a new kind of student, who I like to call the innovation workforce. And they drive hardware virtualization to drive more value from innovation. And that means we create models of reality that we can manipulate faster than we can manipulate reality, so that we know where we want our physical materials to go. And then finally, because we have these virtualized models, we can provide nationwide virtual access for a large group of outsiders to benefit from all the work that we've done, and thereby capture the value of the research we've created and spread it throughout the United States. So, as I said before, IMDD represents a huge opportunity to do this. It's evolved into becoming the first innovation center for platform technologies, and better, I look to the IMDD for that next generation of San Diego companies that have been creating and capturing value. Now, we all know many of the older companies, Linkabit, Qualcomm, Viasat, Cymer, Genomatica. But those of you who have been looking in the newspaper recently may have noticed Lucira Health, first company to provide an at-home COVID-19 test kit. That is a San Diego company. I look to San Diego for creating even more companies like this. And so the great opportunity that IMDD represents and that a partnership between engineering and physical sciences represents is that we are going to build the ecosystem that empowers material science students to become tomorrow's innovation workforce in a very wide range of industries. So I want to thank everyone for your attention. I hope that you like and share this vision that I have. And please be assured that Steve Boggs and I are strong partners along with our faculty trying to make this grand vision become real. Thank you.